And I want to officially welcome you all to Berkley Coding Academy. That is the organization that I run. So let me just tell you a little bit about it. We teach data science to ages 12 to 18. We have had younger students too. If you're ready for programming, we're happy to have you. Our curriculum includes Python, data analytics, machine learning, and AI. We run a popular summer program. It's been voted the best of by Parents Press in 2022 and 2024. These include interactive lectures in which we code together to learn new material. We will actually do some of that today. Also includes cohort time where students will solve problems in smaller groups and work on developing projects. We are a project-based program. And we also provide one-on-one classes year-round, also flexible dates and times. And you can learn more about us at berkleycodingacademy.com. Okay, slides will actually be provided to you at the end. Okay. Oh wow, sorry about that. The sun is coming in. Let me just adjust a little here. Okay. So what we're going to do is we're going to code together, and the way this is going to work best is I'm going to open up a Colab notebook and then give you all an opportunity to make a copy of it. Okay, so it has some starter code with it. Recommendation is that you are logged into a private Gmail account. Google placed a block on these in school accounts, and so a lot of, say, I know in public schools, like, it won't work. Okay, but if you have like a private Gmail account or a generic web browser will also work. It should, but the advantage of the private Gmail account is that the code will store for you and you can refer back to it at any time. Okay, with that said, let me go ahead and share with you actual code. So what I'm going to do here is get a link copied and put it in the chat. And then I will share with you on my screen what you'll be seeing. Okay, so I'm putting in the chat right now a link. And so if you all could open that, and I'll show you what you should see through another screen share, and then tell you what to do. Okay, so let me screen share again here. Okay, so hopefully you all see the screen. Let me know, take some confirmation in the chat. Just people let me know, like, yes, you see the starter code, or anybody let me know also if you don't. Try to get a handle on this, guys. Can people share with me? Okay, at least I can see it. Great. Okay, let me show you what to do now. Okay, what you have is my copy, and you actually want to make it your own copy. So the way you do that, so let's all do this together. You go into the code and you click File, Save a Copy, and Drive. Okay. Again, go to File. Oop. Sorry about that. File, Save a Copy, and Drive. And when you do that, it's going to make a unique, like a new copy. Okay. And you see this copy here, and then you can just get rid of copy. You could call it anything you want. It's a BCA presentation. You can put your name at the front. You don't have to put anything at the front. But when you do that, it becomes your own copy. Okay. So now what we're going to do is go over some of this initial code that we all have together. Okay, so those are the slides that you can refer to later. Now, the way you run cells in Google Colab, the way you run code, you can press that play button if you really want to. You can also hold the shift key down with one hand and press return. Okay, you've got to run the coding cells for this stuff to be able to work that we're going to code together later. So what's happening here is Pandas is Python's data analytics library. That's generally what a lot of people use to analyze data, right? So this URL, it's a bunch of data. It's a raw GitHub file. You can only get specialized URLs to work like this. And then Pandas has a read function that actually transforms this raw data into what's called a pandas data frame. And once you have a data frame, you can do a lot of things with it, like dot head, look at the first 5 rows, and here we have the data. Okay, to build a machine learning model, you have to have data. And this is a heart disease data set. This is a bunch of data on people. I can tell you, for instance, CP stands for chest pain. You know, they're giving a score as to how much chest pain they have. And at the very end, we see target. And the target column basically means 1 is they have a heart disease and 0 is that they don't. And the question here is, can we use machine learning to predict whether somebody has a heart disease or not? Can we take all of these other columns, okay, besides target, and use those to determine whether somebody has a heart disease or not? In effect, machine learning is a solution to mathematical problems. Okay, so let's go down to the next block of code. And again, press shift and then return to run it. And all we're doing here is we're specifying what is X and what is Y. You can think of X as the input. So we're basically setting X as input to model, and then Y is the output. And again, think of traditional like math, you know, X is your input variable, Y is your output variable. Okay. And then that is all of the starter code that we have. So before I proceed, does anybody have any questions? Or I see at least one person said it doesn't work. Sorry, I wasn't prepared for the sun coming in. I'm going to shift to the other side here. If it doesn't work, I would try a different browser. I think that's probably your best bet. And you can also try logging into a private Gmail account. Technically, you could copy and paste the code into any Python setup and it would work. Although the reason why we use coding notebooks and data science is because, like in that df.head, you want to be able to see the results of your data. Okay, so the next part of this, I'm actually going to go back to some different slides because what you have to do when you're building a machine learning model is you have to choose an algorithm. Okay, you're choosing a machine learning algorithm. There are so many. There's linear regression, logistic regression, decision trees, random forest, gradient boosting. And so we're going to use logistic regression. And I have some slides to give you all a brief introduction to logistic regression. So we'll go over those kind of quickly and then we'll code it up together. Okay. So I'm going to share a different window with you all. And let's just talk a little bit about what logistic regression actually is. So it uses this. This is the sigmoid equation. It's 1 over 1 plus e to the negative t. You can think of it as e to the negative x. E is about 2.7. I realize some of you probably don't know that number, but just look at the curve, okay? You don't have to know the equation. The point is more, look at this mathematical curve. Now, the x values are all positive, and what we want is for everything to get mapped to 1 or 0. So what you do, you take all the positive x's and you just map them to 1, okay? That's stepping out of the sigmoid and doing it, having it do what we want it to do. Similarly, all the negative x values, what you're going to do is you just map them to 0. So anything on the left side goes to 0, anything on the right side goes to 1. Now it's interesting, kind of these values in the middle, they have more uncertainty, right? They're close to each other, but clearly you can see still right side goes to 1, left side goes to 0. Now the sigmoid, the curve itself, it ranges from 0 to 1. So that's the red curve. And these values, what's really cool is you interpret them as probabilities. Okay, let me show you how that works. So this point is a value of 0.99, meaning that's the y value here. And so there's a 99% probability that it belongs in class 1. That's how you interpret it. Similarly, if you go down here, this point is a y value of 0.2. So there's a 20% probability it belongs in class 1, or you could say 80% probability that it belongs in class 0. So you're going to map it to class 0. If you go toward the middle, this point is almost indeterminate, right? But it is a little to the right, so it's greater than 50%, and it would be placed in class 1. Okay, so let me just go over brief slides. How does logistic regression work? Sort of a summary of what we were saying. Weights, just think of these as numbers, multipliers, are randomly chosen to multiply each column. Okay, when you add those together, that's actually linear regression. When you sum those, that's the input to the sigmoid. Sort of like, they call it t-value because x is the input for the machine learning model. You think of it as your t or your x. And then you place it into the sigmoid, which is that it'll land somewhere in the red curve, and it'll map to 0 or 1. Now, the percentage of correct predictions is going to be returned here. And then basically you adjust the original weights depending on the error that you get, because they're actually randomly chosen to begin with. There's a technique called gradient descent that uses calculus. It's pretty standard for all machine learning models, which is it goes back and it updates to try to minimize the error. And you do this procedure again and again and again. So you go through multiple iterations and you continue until the error is minimized. Okay, we're going to code it up now. So this is the part where it's just really cool if, you know, we can all do this together, because in the coding, right, it's you can enter the small group of people who have actually coded machine learning models, which is really exciting. I realize this is kind of fast, but I wanted to get you all something, I don't know, really exciting. Okay, so I come back to code. And here we go. So once we know we're going to use logistic regression, so again, code with me. The first step is to, and you don't have to do the hashtags, which are just comments. It's not like actual code. Is to, well, actually, we actually need to get the model. Okay, so here's how you do that. From sklearn, that's a Python library where the models are. Dot, oh wait, let me just check back here. Sometimes, well, actually, I'll show, well, let me show you. If you ever forget where a model lives, you can actually check, you know, if you type it in, logistic regression, okay, this is what we're using. And it's, okay, it's in the linear model part of the library, which is up here. Okay, so if it's from sklearn.linear model, and then you import logistic regression. Okay, so basically all that's doing is, and we'll go ahead and run them a line at a time so that you can make sure the code works. If you get any errors, I would say just try to make sure that it's the code is as it is. If we have a chance, I can try to go back and look at a couple errors at the end. Okay, so this is the model that we want. We now have it. So step number 2 is you initialize the model. Initialize model. And that's done. You just create your own variable, call it, say, model. And then, of course, we're going to use what we just got, which is the logistic regression. Okay, and you want to use parentheses because this is a function. And when you do that, it's blank. It doesn't have any weights or anything like that, but it is ready to now to be used. Now, this is the golden step. Okay, this is where all the magic happens. You fit the model to your data. Okay, and that's done as follows. Now that you have logistic regression as a model, it's actually .fit. And in parentheses, you put capital X, lowercase y, which is how this is defined up here. This is standard notation. Capital X is to indicate many rows. Lowercase y is to, or sorry, many columns. Lowercase y is to denote a singular column. Okay. And when you run that, all the code, it all happens. I'll correct this error in a sec. All the kind of randomizing of weights, optimizing the model, like it happens that quickly. It just happened. Okay. The model has been built, believe it or not. And then there's one last step typically, right? We built the model, but we have no idea how good it did. Like, did it fit the data well? Well, you check by scoring the model, and it's model.score on X and Y. And if you run that, you should get something around 85%. And those are the 4 core steps to build a machine learning model. I'm actually going to put them all together in the same coding cell so that we can see it all together. So we get the model. I'm just copying and pasting here. If we initialize the model, we fit the model, and then finally we score the model. And then running that all together, you can see I get the same 85%. The issue is that they've changed sklearn. You can see it says number of iterations reached its limit. It hasn't converged, and the way you can fix that, the maximum number of iterations, if you change it to something like 2000, that error will in fact disappear. Okay, so there is like this is how it's kind of like it's a little bit simplified, but this is the core code to building real machine learning models. Just quickly recap. You got to have data, right? And you got to know how to get your data in to a coding notebook. You've got to specify your X and your Y, okay? And again, it's just X is what I'm going to use to try to predict Y. And then once you have that, the steps are you're choosing a model. Typically, one would choose quite a few to compare them. You import it, you initialize it, you fit it to your data, and then you score it on your data. Although I will tell you that typically you would separate out a test set that's different than the fitting test, because it's not really about curve fitting. It's about how well is the model going to score on data that it hasn't seen before. Okay, and with that, I'm going to stop because let me stop sharing here. Basically on time, and I'll just leave you all with some concluding comments because I know you have another thing to go to. That was fast. That was fast for me. But in effect, like at Berkley Coding Academy, that would be like the second week, second day of a 52-hour program. And that lesson would be more like a 40-minute lesson, and then you would go into smaller groups and like code it out on your own data and practice. So happy to answer any questions that come up. If you guys want to put them in the chat, you can click on the slides from that link. You can just go to berkleycodingacademy.com. You'll see my email and phone number as the direct contact. So you can also contact me directly that way. So I will stop there. But again, I'll just hang out for a little bit. If anybody wants to put questions in the chat, I do know you all have other things to go to. And with that, I will thank you and congratulate also all of you who were able to get that code in. So, and then I guess I can provide final code to you all later for those of you who couldn't get it. So thank you all and take care.